Now, when we think of AI models, you might think of companies like, ChatGPT. When you're thinking about open source models, you might think about Llama and DeepSeek and things like that. And when you think of the hardware, you probably think of NVIDIA. But did you know that NVIDIA also has its own family of open models? And recently it's just announced Nemotron 3 as a family of open models. So Nemotron 3 comes in three different sizes: Nano, Super and Ultra sizes. Today we're going to be looking at the Nano one because you can actually run that locally on your own hardware. Now, it is more than just an open model. NVIDIA are also releasing some training data sets and some reinforcement learning environments and libraries that help build specialized AI agents. That's the important thing. If you want to take this model and then specialize it even more, they're giving you the tools you can to do that. So not just the model, also lots of tools around it. Now, I said it comes in three sizes. We're going to be looking at Nano. Nano is a 30 billion parameter model that activates up to 3 billion parameters at a time. Why is that? Because it uses this mixture of expert architecture. So there are kind of like lots of little models built into the overall big model. And when an expert gets activated, it then answers the question. And those are 3 billion parameters. Now, there are bigger ones. The Super is a 100 billion parameter model with 10 billion active parameters when using the multi-agent applications. And then there's the Nemotron 3 Ultra, which is a 500 billion parameter model with 50 billion active parameters per token for complex AI applications. So as I say, we're going to be looking at Nemotron 3 Nano. It's available on lots of different open source AI platforms, including Ollama. Okay, and I've downloaded it and I'm going to run it in Ollama, and I've got an RTX graphics card which really does help the performance of this model. Okay, so here I am in Ollama. I've got the Nemotron 3 Nano loaded. Now I'm going to ask it some logic questions, some reading comprehension questions, some writing questions, and some programming questions. Now we'll just start with the one that I always start these videos with, and that is Alice has 5 brothers. She also has 3 sisters. How many sisters does Alice's brother have? Now this is a thinking model, so when we click on it, we're going to see it output some thinking tokens. And once it's output the thinking tokens, then going to come up with a final answer. So here it says here, Alice herself is a girl. She has 3 brothers. So therefore there are 3 sisters. And it goes to work it all out. Let's see what the final answer it gives is. Therefore, each brother has the same count of sisters, namely 4, which is correct. Now remember, it wasn't that long ago that these models would answer 3 because it didn't understand to include Alice in the list of other sisters. Now another question I ask is about hourglasses, trying to measure amount of time. Now the first one, it gets right. I won't show you now. It says if you have 2 hourglasses, one that measures exactly 10 minutes and another exactly measures 5 minutes, using these 2 hourglasses, can you measure exactly 15 minutes? Now I gave it that one and it did that one absolutely correct. So we'll skip on to the next one, which is you have 2 hourglasses, one measures exactly 7 minutes and the other exactly measures 11 minutes. Using these 2 hourglasses, can you measure exactly 15 minutes? If so, explain the steps involved. Now, unfortunately, it doesn't get it right. So it's saying here H1 is a 1-minute sand clock, H2 is a 2-minute sand clock. It's already just kind of gone down the wrong path. It gives loads and loads of, maths here and explanations and notations, but basically it doesn't even get it nowhere near right, which is a shame because the 10-minute and 5-minute one, it got that perfectly right. So in terms of advanced logic, now remember this is the Nano version, so I'm expecting different from the bigger Nemotron 3 models, but for this Nano version, it can't get that right. Okay, so the next one is about reading comprehension and about instruction following. You are an English teacher helping a student with an exercise. It's important that you follow these instructions precisely. Read the following text, then pick the most unusual word in the text. Find a one-word synonym for the word you have picked. Take the synonym and reverse it. E.g., the reverse of spoon is noops. And then here is the text. And normally, most AI models pick quixotical as the most unusual word, and I think it's the most unusual word. The struggle is to actually find a synonym and then reverse it. Well, let's see what happens. Okay, so it's given us just a straight answer, and that looks like there's the reversed word. Utopian, I think, is what it's done. We could maybe look at the thinking here. Let's scroll down through the thinking. So what's it said? We can see idealistic, utopian, yes, utopian, idealistic, impractical, and it's picking the word, I guess it's quixotical. That's what it normally picks. Let's see if we can find it here. Probably the most unusual word is quixotical. Yes, so there you go. And it's done the reverse of that, utopian. That looks to be correct. Okay, more reading comprehension. Read the text below and answer the following question. The 16th century was an age of exploration. What's there? Cosmic, land, mental, common man, or none of the above. Then there is some text here about Magellan's voyage, and it just gives you some history here. You've got to understand that text and then answer this question. Then we've got 2 follow-up questions. So let's see how it does. It's just come back and said B, and B is land, so that's the correct answer. So it has given us the correct answer, B, land. The 16th century was an age of great land exploration, so that's really good. Now let's ask it another 2 follow-up questions based on the same text. So we're keeping the same window open here. So it's saying A, north and south, which is also correct. And the final question, again based on the same text. Let's see how well it can do. A, entanglement. That is absolutely correct. So that's good. It's able to read this text and give answers. What I like about this is actually just given the answer A, B, C, D. It hasn't kind of given us loads of spiel and stuff and everything. And I suppose a reason for that is a lot of it's here in the thought, which is hidden, and then it just gives us the final answer. Okay, so let's try some creative writing. Create an outline for an essay, 1500 word essay on the Battle of the Bulge. So to do this, you've got to have some knowledge of history. Okay, the Battle of the Bulge, the turning point in the European theatre. Okay, so it's introduction, the Battle of the Bulge, decisive point, World War II, yes. German motivation, Allied forces, the geography of the Ardennes. This is good. So it's worked out what the battle is, and it's given some a good outline here. So I'm just going to accept that without reading it too much. It seems to be fairly good. It kind of understands what's going on. So that's a good answer. Another creative writing test. Create 20 interesting blog titles from this. Could open source software be the answer to all your proprietary app problems? Let's see if we can create 20 titles. Here they are. Is open source the cure for your proprietary pain point? Yes, good. I like that. When free code meets paid apps, solving the ultimate dilemma. Okay, I'm not going to read all 20 of them, but let's see. Did it do 20? Yes, great. So that seems to have done a good job there. One final one for writing. Write a review of the 1977 film Star Wars Episode 4 A New Hope, in which each sentence begins with the consecutive letters spelling the director's name in order. Use short sentences. Now, I haven't mentioned here that the director is, of course, George Lucas. So we're expecting it to have some knowledge here, and it's expected to be able to talk about the film at the same time use this kind of funny format that I've asked it to use here. So let's go ahead and see what it does. Starts with its thinking. I can see it flashing up the word George Lucas there. Okay, let's have a look. Georgelucas. Brilliant. Groundbreaking visual, still spark awe. Energetic score drives adventure. Optimistic heroes shine brightly. Okay, and so on. So that's good. So its creative writing skills seem to be pretty good. Now we've got 2 more tests, and these are programming tests. Write a program that takes the phrase Gary explains, counts the total number of alphabetic characters in the phrase, ignoring punctuation and spaces, so the exclamation mark wouldn't be counted, for example. Multiplies that count by 7, converts it into hexadecimal, reverses the digits of the hexadecimal, and finally prints out. So this is really, can it follow a real specific set of instructions for a Python program? And let's see what it can do. Okay, so here's the code that's given us. Let's actually run that. Okay, so here's the code cut and paste into the Python playground here. Let's click run, and there you go. 4-5 is the correct answer. I know that because I wrote the question. So that is correct. And so there we go. For a simple programming task, it's certainly able to do it. Now I have a more complicated programming task. Write a game of tic-tac-toe, that's noughts and crosses for those of you in Britain, using machine learning. Write the game in Python. There needs to be 2 modes. The training mode, which repeatedly plays itself and learns the strategy to win. The other mode is to play against a human once the training is done. Now, bigger models in the cloud can do this. Let's see what this local one running here on my PC, on my RTX graphics card, let's see what it can do. Okay, so it's created some Python here, still outputting it. Okay, so that looks, looks like it's doing what I asked it to do, but of course the real thing is to run it now. So we're going to copy that code and run it. Okay, so we'll paste some code into a Python file here and we'll run it. Oh, I see. So there's a usage to it. So we have to say which way we're doing. So we're going to say train. Unfortunately, that fails. So why does that fail? Train, self-learning, tic-tac-toe. See if I've made a mistake, basically, I'm trying to work out. Doesn't seem to be. Let's just try play to see if it, yeah. Okay, so maybe I could reiterate this through and ask it to try to fix the problems, but on a one shot, it didn't manage to do it. So there we go, the Nemotron open weight model with some additional training data that allows you to create specialized agents from NVIDIA itself. So obviously it's very optimized for NVIDIA hardware. It seemed pretty good at simple logic. It failed at complicated logic. It was very good at reading comprehension, very good at writing, and it was okay, passable at programming, but again, complicated programming failed. And this is all the Nano model. As I said, there are the bigger models as well. So overall, a pretty impressive model that you can run locally on your PC. Okay, that's it. My name's Gary Sims. This is Gary Explains. I really hope you enjoyed this video. I've got, how many videos have I published here now? 787 videos. So if you want to watch any of those other videos, please do check them out and consider subscribing to the channel. Okay, that's it. I'll see you in the next one.